So chapter 5, tissues. If you take a look in your book on page 67, electronic 154 paper copy, you'll see several more terms that you will need to know. The real meat of the chapter starts on page 68 when we start introducing the 4 types of tissues. So the 4 major types of tissues. You will need to know table 5.1 essentially. You will need to know what the tissue is, what its function is, where you find it, and distinguishing characteristics. Is everybody clear on that? So up first, we have epithelial tissues. If you wanted to sum up the function of epithelial tissue in one word, it would be protection. That's not the only thing it does, but that is by far and away the major thing that it does. It also is involved in absorption, secretion, and to a lesser extent, excretion. You may not think of epithelial cells as secreting things, but if you think of sweat, you think of mucus, you get an idea now, aren't you? It also functions in absorption, primarily from the small intestine. Where is it found? Basically, it is found on any organ or system that is open to the outside of the body. So your skin, obviously. But it also lines your respiratory passages, the digestive system, the urinary system, genitalia, lines blood vessels, anywhere that's open and needs protection. Does everybody see that? The main defining characteristics: no blood vessels. They actually do not have their own blood supply. Generally, though, they don't need it because it is only a few layers thick at most. Rapidly dividing. One of the classical side effects of chemotherapy is hair loss, isn't it? Another is nausea. That's because the hair follicles are considered epithelial tissue. Epithelial tissue lines the entire digestive system, and chemo drugs target the fast dividing cells. So they kill the hair follicles, they kill the lining of the digestive system. And finally, they're tightly packed together. You're not going to have a lot of intercellular space. Frankly, you don't need it or want it. You want your skin to be waterproof, don't you? You want it to keep out bacteria and viruses. And it frankly does an amazing job of that. Next up is connective. Connective tissue is probably the most diverse group. Literally, if I had to sum this up in just a couple of 3 words, it would be holding things together. It literally is in the name. It connects. Now, some of these have specialized functions. Some of them you may not think is connective because they're not even solid tissues. Blood. Bone is solid. You've got adipose tissue. You've seen that a couple of times already in lab, haven't you? Big, thin membrane cells that look empty. That's because they're storing fat droplets. There's nothing in there but lipids. They support They protect, they bind, they fill spaces. Where do you find it? Everywhere in the body. Unlike the epithelial tissue, connective tissues typically, and you might want to underline that word because it's not always, they typically have a good blood supply. They're very often surrounded by a specialized ECM, or extracellular matrix. And when I say specialized, I mean very specialized. In bone, the ECM is solid. In blood, it's actually liquid. You get the idea. You'll have a fair amount of space between these guys.
What was that about the ECM? What was that about the ECM?
Specialized.
Specialized?
Mm-hmm. They put out a lot of things between the cells. Proteins, minerals, liquid. You'll probably end up spending as much time in connective tissue alone as you will all of the others put together. It's just that diverse. Third is muscle tissue. If you put down that its main function is movement, I'll give you credit, but that's not entirely correct. The main function is to generate force. To generate force. The force is typically used for movement. Does everybody see the difference? It will always be attached to something. Skeletal muscle is attached to the bones. Smooth and cardiac are connected to organs, blood vessels. And unlike other cells, they can contract under a specific stimulus. They can contract under a specific stimulus.
So where's the location of it?
Throughout the body, attached to the bones or the organs. In case of cardiac muscle, where is it located? In the heart. It's only in the heart. Make sure you know that. And then nervous tissue. Nervous tissue essentially transports information, transmits and receives information. It does a lot with that information. It coordinates, it regulates, it stimulates, it integrates. The author who wrote this textbook apparently loves nervous tissue because he devotes a lot of time and effort into the chapters on that, as you will see at the end of the semester. It's almost an overload. So you'll find it throughout the body, but the best answer would be the brain and spinal cord. You could even just say the nerves themselves. And what distinguishes this is the communication. You can transmit and integrate signals from throughout the entire body. Any questions about the 4 tissue types? I promise you, you'll see that as a test question on exam number 2. It's just so important. The whole chapter is summed up right there in that one table. That's why I wanted to make sure you knew where to look. That's why I wanted to walk you through it. Just know it. You have to. There's no way you can be successful without that. Is that fair? All right. So intercellular junctions. Inter means between, cellular means cells. So between cells. How do cells connect with each other, and how do they communicate with each other? And this is through intercellular junction. You've basically got three types. Again, if you want to have a place to refer to, I refer you to table 5.2. We're still on page 68. I believe it's 155 in the paper copy. And the first of these are called tight junctions. Tight junctions. And as you might imagine, there's very little open or free space between the cells. Essentially, the cell membranes are fused. The cell membranes are fused. These are typical of epithelial tissue. Best examples probably found in the small intestine. Am I going too fast? Second are desmosomes. Desmosomes. And I like the way the book describes these as spot welds. So in other words, you've got two loose cell membranes. Everybody see how my hands are doing right here? And they connect here, but then you got this open space. They'll connect up here, then they'll repeat it. So you've got these alternating points of attachment with an open space between them.
What are those called again?
Desmosomes, Desmosomes.
So what does the tight junction do again? The tight junction?
What about them?
I'm just saying, how do they connect again?
They fuse the plasma membrane of adjacent cells. And you'll find desmosomes in the cells of the outer skin layer, the outer skin layer. It may sound a little surprising given that it's the outermost surface, but the cells on the outermost surface eventually die and slough off, don't they? So you want to be able to get rid of them so you don't get this thick layer of skin. And then the final type are called gap junctions. Gap junctions. And what these are essentially tubes. We're used to thinking of cells as separate, distinct entities, right? But if this is a cell and this is a cell, they may have a very thin little connecting tube there, and you can actually get cytoplasmic streaming flowing from one cell to another. This allows the exchange of materials between the cells. Good examples of this are smooth muscle in the digestive system and cardiac muscle in the heart. Did you have a question?
Yeah, I'm just wondering. I know there's another thing. I know nerve cells have this little gap between them. Which one would that be?
None of these, because they're not connected. That gap is called a synapse, and it's a special case.
Yeah, it transmits neurotransmitters.
Yes, but it is a literal gap. That is the entire point.
Mm-hmm. Yeah, I have a psychology class, so I've been learning some of this stuff.
When we get to the nervous system, you'll get more about that than you ever wanted to know.
Mm-hmm.
So is everybody okay with the tissue types? Everybody okay with the three types of intercellular junctions? Yes or no?
So you said the locations of them as well?
Yeah, you need to know those as well.
Yeah, I just...
All right, so epithelial tissues. These are fairly diverse. You'll find them in lots of different places. They are also diverse in function, structure. Main thing is they line the organs, the hollow spaces of the body, and the skin. It will always have what we call the apical surface, or the free surface.
What was the first word that you said?
Apical. The apical surface is the one that's open to the outside or to the internal hollow space. It's not connected to anything. The basal surface is the bottom. It's where it connects through the basement membrane to the tissue beneath. So the apical surface is the top, the basal surface is the bottom. The basement membrane is what connects it to the other tissue. Now remember, these typically lack blood vessels. So they get their nutrients through diffusion. They get their nutrients through diffusion. It passes out of the blood vessel into the connective tissue, then to the epithelial tissue. And you're going to have two types of this. Epithelial tissues consist of thin, flat cells, and that is squamous epithelium. If it is cube-shaped, it is cuboidal. If it is long and tall, or thin and wide, thin and tall, it's columnar. Simple is one layer. Simple is just one layer. Stratified means more than one layer. Everybody clear on that? If it is stratified, only one layer will be open to the apical surface, and only one layer will be connected to the basement membrane. So, simple squamous, flat and tight. These are common where you find diffusion and filtration. So the alveoli in the lungs, those are the little air sacs. That's where the actual exchange of oxygen and CO2 takes place. You'll find simple squamous there. The inside of the blood vessels, the inside of the lymph nodes and the lymphatic vessels. It's not very tough, and it's very easily damaged. Make sure you get that down. It's one of the reasons why smoking or vaping is such a bad idea. You're constantly damaging that tissue.
Simple squamous.
Simple squamous. Yeah, even if you've smoked for 5 years as a teenager and quit, by the time you're my age, you'll still have the effects of it. Next up, we've got simple cuboidal. These are a little bit thicker than the squamous. Rather than looking like a flat plate, they'll look more like a box, about as broad, wide, and tall, generally is a cube. They line the central channel or lumen of tubules and ducts, primarily in the kidneys, ovaries, thyroid. They also help secrete things, which, thinking about finding it in those various glands, that makes sense. And then the last type is simple columnar, simple columnar. And these are very thin and tall. They may have cilia on the apical surface, C-I-L-I-A. And the cilia are little finger-like projections that stick out, and they can move substances along so it doesn't get caught up and stuck. Example of these would be in the trachea, the bronchial tubes. You breathe in pollen or bacteria or viruses or dust, it gets caught in the mucus lining those passages. The cilia then sweep it up and you swallow it and it goes through your digestive system and is excreted. So everybody understand those? In the ovaries, they'll help move the oocytes to the uterus through the fallopian tubes. Non-ciliated simple columnar also lines the uterus and the digestive tract, both intestines, the stomach. Since they're so long and narrow, that gives them a thickness that allows them to fulfill their function of absorption, but also to act as a cushion and a protective layer for the tissue beneath. Gabby, you got a question?
No.
Okay. You look lost. I want to make sure. Pseudo-stratified columnar. These look like they are in layers. But if you look more closely, you will see that they are not. That's because they vary in shape and size. They are all connected to the basement membrane. Located among these, you'll have some specialized cells called goblet cells, G-O-B-L-E-T. The goblet cells secrete mucus. And these guys sweep it away. And as I said, their function is as a trap. Mucus is secreted by the goblet cells, and that's part of the secretory function of this epithelial tissue. Mucus has two functions. This is not listed in the book, so you may want to get it down. Number one is lubrication. It helps reduce friction. Number two is sticky. It's a trap. If anybody has ever spent time around a toddler, you know what I mean. I see a few of you nodding. I may not have kids, but I have babysat, yes. Basically, it's just a fairly thick solution of polysaccharides in water. If you've ever spilled soda on a surface, you know it gets tacky, doesn't it? Same principle. Want something that'll gross you out? Believe it or not, you produce and swallow about 1/4 of mucus a day. You don't see it or think about it because that's part of your normal bodily function. All right, stratified squamous. Many layers of cells. And these, at the bottom, are almost cuboidal or columnar depending on where it's located. And then as the layers pile up, they get flatter and flatter. If you take a look at figure 5.8 in your textbook, on page 161 paper copy, page 69 electronic, you'll see that layering effect. They have a very, very good picture there. And the cell division is occurring at the deeper layers where it's either cuboidal or columnar, and it pushes the old cells out. Eventually, they get so far out that they're no longer receiving the nutrients that they need and they die. And then they get sloughed off in contact with things. Your clothing, the sheets in your bed at night, shaking hands with somebody, picking up your pencil. You're leaving behind dead skin cells everywhere. So the outermost layer of the skin is going to be this stratified squamous. Stratified columnar epithelial. Several layers, and this means that it's going to be found in areas where you need more protection. The urethra of the male, the ducts of the exocrine glands, those are sweat glands. These are the ones that carry sweat or urine away. If you want to see a look at page 162, figure 5.10. Did I cover cuboidal?
No, not yet.
Okay, stratified cuboidal, they typically line the lumen of a gland, the lumen being the hollow inner space. Last one, transitional epithelium, transitional. This is not considered either stratified or squamous. It has properties of both. The main thing here is that it is found in the bladder and the upper urethra. The bladder contracts, it expands, it's like a balloon. The key word you want to get down in your notes is elasticity. Elasticity. It stretches. When it stretches, the cells elongate. When it's distended, they contract. Table 5.3 summarizes the different types of epithelium. Is everybody clear on that? And like I said, I know that's not the most interesting part of this, but again, you do need to know those. Any questions? All right. Glandular epithelium. These are cells that produce and secrete a substance. They produce and secrete a substance.
What was it called again?
Somebody raise a hand.
What
What?
was it called again?
Glandular epithelium. Groups of these cells combined together are called a gland. A gland. G-L-A-N-D. There are two major types we're going to look at here. The first are endocrine glands. Endocrine glands get secreted inside the body. They go into the blood or into tissues directly. Make sure you understand that. We are not going to get into a discussion of the endocrine system. That's chapter 13. You can get into that in Anatomy and Phys 2. Everybody clear? So next up, we have exocrine glands. E-X-O-C-R-I-N-E. The exocrine glands we are going to talk about now, because those are the ones that get transmitted to the surface of the skin, or into the digestive tract directly.
So we won't be tested on endocrine glands?
On what?
On the endocrine glands?
You just need to know what they are. The testing will be on the exocrine glands, because we're going to get into more detail on that, what they are, the different types. But that's a good question. Everybody clear on that? Now, the exocrine glands can be either unicellular or multicellular. Unicellular, they're just a single cell. The goblet cells that I mentioned, they're an example of that. Goblet cells are unicellular. The multicellular come in two types. Simple and compound. Simple means that the duct does not branch. So you've got a little group of cells right here at the base of a hollow tube. Everybody see that? And these produce it, it gets secreted straight out. That is a simple. If it branches, it's a compound multicellular gland. Compound. Page 164, figure 5.12. You see some that are there. Does everybody see how they have a single duct leading to the surface? Now, if you look on the bottom, you've got multiple ducts feeding in. So the types of each, table 5.4 on the same page. Simple tubular, it opens directly onto the surface. It's a straight tube. These are ones that you find in the small intestine. Simple branched and tubular, gastric glands in the stomach. Simple coiled, where it looks kind of like a spiral. Those are typically the sweat glands. And then simple branched alveolar. Alveolar meaning sac-like. Does everybody see that in figure 15 or 512? Those you find in the sebaceous glands. The sebaceous glands are the ones that secrete oil onto your skin. And then finally, compound glands. The ducts branch repeatedly. Compound tubular, these are in the male urethra. And compound alveolar, mammary glands, milk in the female. Everybody clear on those? Don't obsess over this table too much. This is not one that would make a good test question. I do want you to know the differences, but don't worry about the specifics so much. Is everybody okay with that? And when I mention things like this to you, several of you have asked me if I would reiterate certain things that I think are important. So that's why I'm trying to do that as we go. Is that helpful? I can't tell if anybody's nodded or not. Okay. So next up is another way to classify them is by their secretions, what they put out. Page 165, table 5.5. This one is important. This one would be an excellent test question. This is one to focus your studying on. So the three types. First up are merocrine glands. Merocrine. And the fluid product, what is secreted, is released by exocytosis. Exocytosis. It just opens up and releases it. Salivary glands, the pancreatic glands, the ones that secrete insulin and glucagon. And finally, the sweat glands of the skin. The sweat glands of the skin. That would be a great list and describe question there, wouldn't it? List and describe the three types of exocrine glands. List and describe the three types of merocrine glands. Apocrine glands or apocrine glands. I've heard it pronounced both ways. In this, rather than bringing it to the surface of the cell membrane and then releasing it, you actually pinch off part of the cell to release the product. It actually pinches off a part of the cell that contains the product. The best example of this, number one, would be mammary glands. They bring milk to the surface. And ceruminous glands. The ceruminous glands are found in the ear canal, and they secrete cerumen, which is what we call earwax. Everybody got that? And the last one are called holocrine glands. Holocrine glands. And in this case, the cell itself just disintegrates and releases its contents. The sebaceous glands that produce sebum, S-E-B-U-M, that's the scientific term for the oil-like substance that we have on our skin and our hair. Any questions? All right, make sure you know the difference between serous fluid and mucus. Mucus is thick and has glycoproteins in it. specifically one called mucin, M-U-C-I-N, mucin. Others release serous fluid, S-E-R-O-U-S. It's typically thin, watery, and acts as a lubricant.
So, mucus, and what was that other one called?
Serous, S-E-R-O-U-S. It's below table 5.5 on page 165. And that's it for section 2. Section 5.3, connective tissue. Most of the body has connective tissue. If you actually divided up the 4 tissue types by weight, the majority of it is going to be connective. That might sound a little surprising when you think of how much muscle mass people have, but when you consider that bones are connective tissue, it makes a little more sense. And you've got 2 different types of connective tissue. Number 1 is what we call connective tissue proper. This is what you would think of when you're thinking of connections and things that are held together. Things like cartilage, ligaments, tendons. The other type are specialized connective tissues. Specialized. These are ones that you probably would not think of as connective tissue. These are things like bone and blood.
Could you explain, you probably were just about to get into it, but could you explain why bone and blood is considered a connective tissue?
Because they do connect parts of the body together. Bones connect the muscles. You have ligaments attaching the bones to the bones. You have tendons attaching the muscles to the bones. It's all connected, right? And I don't think, sure, I don't mind, because it's, like I said, it's not obvious. And blood, you don't think of blood as a tissue, but it does circulate. It does connect things, right? Basically, a blood cell makes it through your entire body in under 5 minutes. Pretty wild. Is that clear enough for you, Desiree?
Yeah.
Okay, what really makes these tissues different is their ECM, or their extracellular matrix. The ECM is going to be composed of 2 things. And yes, you do need to know this. Yes, this would be a good test question. Number 1 are the protein fibers. The protein fibers. And number 2 is something we call the ground substance. The ground substance. The ground substance is what typically varies the most. It can be anything from essentially water, which is what you'll find in the blood, to a solid like calcium phosphate that you find in the bones. The ECM is what allows. Piper, you need something?
Oh, she was
No,
just
I was
gonna
just telling her what you said.
Okay. The ECM essentially what connects the parts together. It is the connective part because it's between the cells. It binds, it supports, and it provides a medium of transport between blood and other cells. It binds, it supports, and it provides a means of transport between other cells. It can be fluid, it can be semi-solid, it can be solid. You may want to get that down. Some of these are rigid, some of these are flexible, some of these are elastic. Your book basically says it's the body's glue. It's the glue that holds things together.
Wait, what was that thing about rigid and stuff? It said you were talking about it being rigid and what was
Yes,
the other?
some are rigid, some are loose, some are elastic, some are flexible. Generally, it's going to be divided into two parts. Number one, the basement membrane. The basement membrane. This is what connects the connective tissue to the epithelial tissue. Then the rest of it is called the interstitial ECM, interstitial. And while I could get into the hardcore biochemistry of what ties all this together, I think that's just a little bit beyond the scope of what we need to know. Does that sound okay? Or would you all rather have the hardcore biochemistry? All right, major cell types within connective tissue. The major cell types within connective tissue. Number one, fibroblasts. Fibroblasts. These are the most common type of cell in connective tissue. They secrete proteins into the ECM. And they help repair injuries. They help repair injuries. Second are called macrophages. Macrophages. MACROPHAGE. The macrophages originate as white blood cells. They then differentiate into the macrophage form. They're sometimes called histiocytes. They can be attached to protein fibers in the ECM. They can also detach and move about. Essentially, they are scavengers and hunters. As scavengers, they'll absorb and break down old, worn-out cells, extracellular debris. As hunters, they will actually seek out and absorb bacteria and viruses. So as you might imagine, their most important role is the immune response. The immune response. And the third type is the mast cell, mast, M-A-S-T. These are also widely distributed. They also originate from white blood cells. They also play an immune role. They secrete two substances. Yes, you will need to know these. Yes, these are important. Number one is a substance called heparin. Heparin, H-E-P-A-R-I-N. Heparin is an anticoagulant. Helps make sure that you don't form blood clots where you don't want them forming. The second one is called histamine. Histamine. Has anybody here got an allergy to anything? Just a few of us. You ever taken antihistamines? That's because these things act as the chemical messenger in the immune response. They are the chemical messenger for a systemic immune response. And I see nobody writing that down. What they do is they release the histamines when stimulated by foreign particles. The histamines stimulate inflammation. They stimulate inflammation. This causes dilation of the blood vessels, which results in increased blood flow. It stimulates vasodilation, which increases blood flow. That in turn has other secondary effects. So when you have an allergy, very often they will prescribe to you an antihistamine to block these chemical messengers so you don't get an inflammatory response. How many of you know what the inflammatory response is? One of you? Two of you, okay. Well, I think we probably need to get this then. So I want you to write down the inflammatory response. What happens when you get an infection or an injury? Has anybody here ever sprained your ankle? What symptoms did you get?
Swelling and pain.
Huh?
Swelling and pain.
Pain, which lets you know that something is wrong.
Blood loss,
Huh?
depending on how severe.
Blood loss if you've got a very nasty cut. I hope you don't get blood loss with a sprained ankle.
I randomly got a cut the other day. I don't know how I got it, but blood was just pouring out.
That's actually part of the response. Swelling was mentioned. What color does it turn?
Purple.
Huh?
Purple and blue.
Starts off red. Gets kind of hot, doesn't it? They tell you to put ice on it. That's because of the inflammatory response. The histamines that are released stimulate vasodilation. So number one, you get increased blood flow. Number two, it makes the desmosomes looser. So you actually open up spaces between the cells, and the blood vessels rather, become leaky. They actually start losing fluid to the interstitial space between the cells. That fluid causes something called edema, E-D-E-M-A. Edema is a fancy term for swelling. Typically, it will get warmer. That's also because of the increased blood flow. Believe it or not, your bloodstream acts as a heater. You are circulating hot fluid. It also will leave the area flushed and red in color. Flushed and red in color. If you have an injury that does not involve an infection, something like a sprained ankle, the first thing they advise you to do is put ice on it. Then they advise you to elevate it. Both of those are intended to decrease the blood flow to the area, to decrease the blood flow. That's why first aid is ice and elevation. That will reduce the swelling. Supposedly it will reduce the pain, although that has never been my experience. And it will also help constrict or contract the blood vessels. If there is an active infection, if it's a cut, you mentioned that you bleed. Heparin actually makes sure that the blood flows for a small period of time. Clotting typically doesn't begin until 5 to 15 minutes after the injury. That is to allow the blood flow to actually act as a fluid to wash away any foreign debris. And I don't see you writing this down, because you want to flush that. Then it will begin to clot. As the blood flow has increased and these interstitial spaces have started to fill with fluid, the macrophages and other white blood cells move to the side of the wound. They begin to increase in number, and they migrate out into the surrounding connective tissue, where they begin to look for and engulf invaders. Eventually, they will consume so many bacteria or viruses that the macrophage itself is no longer viable, and it will die. Other macrophages come along, they consume the invaders, they die. You see where I'm going with this? And eventually that fluid is going to end up filling with debris from the dead macrophages and the dead invaders, whether they're bacteria or viruses. That fluid is now called pus, P-U-S. You ever get a pimple and you pop it? That's what comes oozing out. That is the generalized inflammatory response. Yes, you do need to know that. Yes, that would be a very good exam question. We don't normally talk about the immune system in detail until the second half of the course, but I want you to make sure that you have an understanding or idea of what it is and how it works. Everybody got that? Okay, back to connective tissue. Fibroblasts, we said they're involved in repair of damage. They do this by producing protein fibers for the ECM. There are 3 types of these protein fibers. Again, you do need to know these. Great list and describe question. Table 5.6 sums this up. So number 1 are collagen fibers, C-O-L-L-A-G-E-N, collagen. These are thick. Collagen itself is the major structural protein of the body. It is the major structural protein of the body. These fibers get grouped into long parallel bundles. They are flexible, but not very elastic. They don't really stretch. You can bend them, but you can't stretch them. Does everybody see what I mean? You can bend them, but you can't stretch them. This makes them very tough. They have a high tensile strength. That means they resist tearing. These are the major components of ligaments and tendons. They are the major component of ligaments and tendons. Ligaments connect the bones to each other. Ligaments connect bone to bone. Tendons connect muscle to bone. They connect muscle to bone. The second type of fibers in the ECM are called elastic fibers. Elastic fibers. The major protein here is elastin. E-L-A-S-T-I-N. These form complex branching networks that are interconnected. That means they are weaker than collagen fibers, but they are much more stretchable and flexible. They are stretchable and flexible. So the collagen fibers give you strength. The elastic fibers give you flexibility and stretchability. You'll find these in areas of the body that are typically subject to being stretched or deformed. Vocal cords, respiratory passages, now, I want to bring up a point to you here when you're looking at the slides in the lab. You may have seen some of these referred to as dense connective tissue, dense fibrous tissue, or white fibrous connective tissue. All of those refer to things made up of collagen fibers, the tendons and the ligaments. Make sure you know that when you're looking at the slides in the lab. If it says elastic connective tissue or flexible connective tissue or white connective tissue, then it's going to be the elastic fibers. Is everyone clear on that? After today, I will expect you to know that. I may give you a test run on Thursday for your lab exam. Would you all like that? Okay, we'll see if we can do that. And then the final type are called reticular fibers. Reticular. R-E-T-I-C-U-L-A-R. Now these are also made of collagen, but unlike the collagen fibers themselves, these are thin, and much like the elastic fibers, they form a branched network. Be sure you know that. That allows it to kind of have the best of both worlds. A little bit more strength, a little bit more flexibility, but it's not completely elastic and it's not very dense. These support internal organs. The spleen is a good place to find them. So whenever you are looking at the connective tissue slides, the main three types you're going to want to look for will be the dense white fibrous connective tissue made up of collagen fibers, and those are going to be your tendons and your ligaments. The second type will be the elastic fibers, or the yellow fibrous connective tissue, vocal cords. And the third will be the reticular fibers, or the reticular fibrous tissue. So those are the three different subtypes of connective tissue proper. Make sure you have that down in your notes. This is summed up pretty good in table 5.6. So, would you all like a mini review for today? No? Well, you're going to get one regardless. First thing we talked about, the 4 different tissue types: epithelial, connective, nervous, and muscle. No function, no location, no distinguishing characteristics. For epithelial tissue, simple versus stratified, squamous versus cuboidal versus columnar. Also, be sure to note the differences between columnar and pseudocolumnar. Note transitional epithelium. The 2 different types of glands, endocrine versus exocrine. The types of exocrine glands: merocrine, apocrine, and holocrine. No function, no location. Connective tissue, know the 2 types: connective tissue proper and specialized. Know the 3 main types of cells: mast cells, macrophages, and fibroblasts. Know their functions. Know the 3 different types of connective tissue fibers in the ECM, being collagen, elastic, and reticular. Any questions about today's lecture? We are done.